Hey, seventh grade. So our learning target for today is I can find the surface area of a cylinder. All right, so you should be on page 15. So we're talking about cylinders again today. We're talking about soup cans, pop cans, things that have a circular base on top, circular base on the bottom, and that rectangle that wraps around. What's going to be different about today's work is we're not going to be focused on filling it or how much it holds. That's called volume. Our work today is called surface area, so the area of the surfaces. So what happens if we were to wrap the pop can or wrap the soup can? So that's really what our work is about today. It's called surface area. For surface area, we're really going to be talking about adding the area of the three surfaces. So we're going to say the area of three surfaces. Sorry about my writing there. So we're going to say area of the circle plus the area of the rectangle plus the area of the circle. That's going to be called our surface area today. But there's a formula that we use for that to break it down. Okay, but before we do that, we're going to talk specifically about the lateral area. So the lateral area comes up in this way. It's really just the rectangle that wraps around. Now, a lot of kids would be wondering why we would be focused on just that lateral area, not the circles. Well, if you think of any soup can, we just have a label that wraps around. We are not covering circle 1 on top and the congruent circle 2 on the bottom. Just the label on the soup can. So there are times when we want just the lateral area, which is really the label. And so that is going to be a very important vocabulary word in our work for 7th grade standards of surface area of cylinders. Okay, so the net of a cylinder we've already covered. So you have this circle on top. You have this rectangle that wraps around. This is called the net. It's what it looks like as a two-dimensional net. It looks like this. And again, I just highlighted that this is going to be, oftentimes we're going to just want to know the lateral surface area or the area of the label. Okay, so there's our net. And it says next to identify the three shapes used to build a cylinder. Well, we just talked about that. Circle on top, congruent circle on the bottom, rectangle that wraps around. And there we have it. Okay, so we're going to find area of this, area of that, add them together, and that is our total surface area. All right, 7th grade, here we go. So go ahead and catch up, actually. Probably working through that too fast for you. All right, guys. So how do we find it? Well, the dilemma that we have a little bit here in the Minnesota State Standards is the formula that they give you on the Minnesota State Standards for the MCA test is surface area is the perimeter times the height plus 2 times the area of the bases, which is fabulous if it made any common sense to most people. It's really a kind of a frustrating formula in terms of a teaching standpoint. So we're going to talk about that same exact formula just in more of a Ms. V trick way, okay? So we're still talking perimeter. Perimeter really in this case is meaning circumference. Circumference, okay? And you know that surface area we've talked about in the area of the base. Well, the base is a circle, and we have 2 circles. Top circle and a bottom circle in a cylinder, and the height is pretty simple to understand. What we do instead is we modify this, and we come up with this formula called surface area. We're going to start with the 2 bases, and we're going to call it 2 pi r squared. So everybody should be saying that in their head. 2 pi r squared plus, and then you're going to say 2 pi r h. Go ahead and say that to yourself in your head. Ready? 2 pi r squared plus 2 pi r h. Okay, we're going to try it again. We have 2 pi r squared plus 2 pi r h. So the surface area in our work today is 2 pi r squared, area of base 1, circle on top, and congruent circle on the bottom, plus 2 pi r h, that's the area of our rectangle. So we're going to go ahead and write those symbols down so we kind of know what's going on here. Here's our 2 circles. That's how you find the area of circle, pi r squared, 2 of them. And then this is our rectangle on the bottom, or just our label. We're going to be using this for the entire unit. You're going to say it so much that you are going to have it locked in your brain forever. Here we go. Surface area is 2 pi r squared plus 2 pi r h. Here we go. Let's give it a shot. So we're going to use the Ms. Volkman way of solving these. And you're going to say surface area formula in Ms. Volkman's class. Here we go. Ready? 2 pi r squared plus 2 pi rh. 2 pi r squared plus 2 pi rh. Again, we're talking circle 1, circle 2 plus rectangle. All right, here we go. So we're going to plug and chug. We're going to start plugging things in now. We have 2. Pi is 3.14. The radius squared. Well, the radius happens to go from center to rim. So the radius in this particular problem is 4, and we are going to square that. Plus 2. Catch up, guys. Catch up. Everybody should be catching up. Pi. The radius, again, is 4. And a little bit tricky here is the height, because some kids will be saying, well, wait a minute, that can's tipped over. Yeah, so the can's tipped over. What if we set it upright? If we were to set it upright, this would be the height of 9. So just pick up the can. You got to kind of pick it up with your eyeballs and have an understanding that if we reorient or change the position of that cylinder, the height would then be 9 inches. So we have 2 pi r squared. Area of the 2 circles. Circle 1. There's your pi r squared. It's 2 of them. Plus 2 pi rh. So you're going to go ahead and type all that stuff in your calculator. Go. Everybody's typing it in. 2 pi r squared plus 2 pi rh. And you should be coming up with the surface area of this cylinder, the amount of wrapping paper needed. The surface area is equal to, not sure what's going on there, is equal to 326.56 inches squared. So you should have 326.56 inches squared. That is the amount of wrapping paper needed to cover, called surface area. All right, guys, let's take a look at this other cylinder. Now, this is kind of a flat, squishy cylinder. Looks like maybe something similar to a tuna can. Maybe we would only want to find the lateral surface area if we were going to wrap this with a label, but it doesn't say that specifically. So in this particular problem, we are going to find the surface area of everything. So we're going to say surface area is 2 pi r squared plus 2 pi rh. Circle on the top, congruent circle on the bottom, rectangle around the middle. All right, guys, here we go. So we're going to plug and chug. We have 2 pi radius. There's our pi. Radius squared. The radius goes from center to rim, so our radius would be 7, because our diameter is 14, so our radius is 7. We're going to square that. Plus, we have 2 pi. The radius is 7, and the height is 2. So that's 2 pi rh. 2 pi rh. So if we break this down again, here's our 2 circles. 2 pi r squared. Circle 1 on top, circle 2 on the bottom, plus 2 pi r h. Sorry, guys. I really wish this, I'm having a hard time with this pen on this tablet. All right, as we start to solve, it's easier if I'm writing on the smartboard. We end up having a total surface area of 395, go ahead and type that in, 0.64 meters squared. That is the surface area of that cylinder, how much wrapping paper is needed. I'm going to give you a chance to catch up and make sure that you are on track with that in example 1. All right, guys. Okay, hopefully you feel good about that. If not, rewind, try it out again. I know that there's not a lot of space in these boxes that I've created. I apologize for that. I'm having a hard time even writing with the pen, so I'm sure you're having trouble. All right, here, let's try this one. So surface area, we're going to go ahead and wrap this cylinder. Surface area. Formula we just talked about. 2 pi r squared plus 2 pi rh. All right, here we go. Circle on 1 on top. Congruent circle on the bottom. Here's that rectangle that wraps around. All right, so we start to plug in. So we have 2 pi. The radius, in this particular case, now we're ignoring this arrow because that gets confusing. This is a full line, which is a diameter, which means that the radius is equal to 3. So we're going to put a 3 squared in there, plus 2 pi. Radius is 3. And the height, now this cylinder got kicked over, this can got kicked over. So if you were to set it up right, the height is equal to 12. So we have 2 pi r squared let's go ahead and take a look at what I just wrote. 2 pi r squared, there's the area of the top circle and the bottom circle, plus the lateral area, or the area of the rectangle that wraps around. 2 pi r h. All right, so we type all that in our calculator. Everybody's typing, go. 2 pi r squared plus 2 pi r h. And you should end up with an answer of 282.6 centimeters squared. That is the surface area of this cylinder. How much wrapping paper would be needed to cover circle 1, circle 2, and the rectangle that wraps around? All right, guys, we're almost there. We have one more to do before a summary. Hang in there. All right. So again, we're going to wrap this cylinder over here. Surface area. Surface area is measured by 2 pi r squared plus 2 pi r h. 2 pi r squared plus 2 pi r h. All right. Here we go. So we have 2 times 3.14 times the radius squared. The radius goes from center to rim there, which is 7 squared, plus 2 pi, radius is 7, and the height is this height here, which it happens to be 5. All right, guys, so we have the area of the two bases. Here's the area of my two bases, plus the area of the rectangle that wraps around. 2 pi r squared plus 2 pi r h. Go ahead and check where I plugged everything in. I'll slow down, make sure you catch up. Everybody's either typing in your calculator right now or catching up through writing. Let's go. 2 pi r squared plus 2 pi r h. Everybody's writing. All right, so we have 527.52 feet squared. 527.52 feet squared. That is the surface area of that cylinder. All right, so what our work was today is to find basically wrapping paper. How much would I need to wrap this three-dimensional figure? So it's really a circle plus a rectangle plus the circle. Now, there will be times in your work today that you will only need the rectangle. You won't need the 2 pi r h's, or 2 pi r squared. You're going to have to sort through that. In your homework, all answers are written on my website as well, so you could check that. But what we've modified the formula to be is 2 pi r squared plus 2 pi r h. Again, these are our two circles here. Circle 1, circle 2, and here is our rectangle. In some of your homework problems tonight, you will be eliminating this piece because you're only going to be wrapping maybe the soup can, so you'll only need the rectangle, so you'll have to be aware of that. All right, guys, so your work tonight, your homework is to do page 16 for sure. Now, if you have a sub today, your sub might say that you also have to do 17. So I guess I'll go ahead and say plan on doing page 16 and 17 for homework. 2 pi r squared plus 2 pi r h surface area, unless the sub is telling you otherwise. 16, 17 due tomorrow. Have a fabulous night, 7th grade.